Right. So this lesson we're gonna learn something very important in high school, probably the most important unit that you'll ever learn in high school. And this unit is polynomials. To begin with, talking about polynomials, we'll first start with the definitions. So, David.
Okay, so these are some pretty important definitions. So the most basic unit of a polynomial and the most important definition in this entire unit would be what is a term. So a term is essentially a mathematical expression consisting of a real number coefficient and a variable with a whole number power.
Efficient. Okay.
So we can write a basic general expression for a term. So here we have what a term is essentially is we can have the variable a representing our coefficient multiplied by a variable x, for example, and then to a whole number power, for example, n. So this would be a basic term where we have a as a coefficient, the x as a variable, and then the n as a whole number power. So some other examples of this would be like 3x. So in this case, our coefficient is 3, our exponent, our variable is x, and our power is a whole number, which is a 1. And then we could have another term. So for example, 4x times y times z. So this time we can actually, a term can have any amount of variables just as long as they're all multiplied together. So in this case, we have the coefficient of 4, and then we have 3 variables, all with the power of 1. So we can also have a third example. So we have 4x squared. In this case, our coefficient is 4, our variable is x, and our power is 2.
Okay, so notice how we said that it must have a real number coefficient. A real number consists of all the numbers on a number line. So another example would be pi x squared, because pi is also a real number. So the coefficient can pretty much be any number you want. However, the exponent of the variable has to be a whole number. So whole number is 0, 1, 2, 3, etc. Okay, so now we'll give a practice for you guys. So is this number a polynomial? Sorry, is this number a term? 5x to the power of pi. You can type your answer into the chat. So is this a term? No, yeah, good job. Because x is raised to the power of pi, and pi is not a whole number. What about square root of 2 times x to the power of 3? Is that a term? Yeah, correct. I mean, actually, no, sorry.
Yeah, it is a term.
It is a term.
When we recall our definition, our only restrictions are at the coefficient has to be a real number, which the square root of 2 is irrational, but it's still a real number. And we can see that the exponent is also a whole number, so that's correct. So this is indeed a term.
David, do you want to give another example?
Yeah, so we can have...
Wait. There's a question. So the variables has to be whole. The exponent of the variable has to be whole, but the variable itself does not have to be. Just the exponent has to be a whole number.
Yes. So we can have a supposed term. We can have negative 7x divided by y. Oh, divide the whole thing by y.
Okay.
I don't think that really makes a difference. But, oh yeah.
It doesn't make a difference, but
Yeah. So is that a term?
yes.
Actually, no. So if we remember back to the last lesson about exponents, we remember that if we have a negative number as a power, that number would also turn into a fraction. So in this case, instead of expressing it as divided by y, we could say y to the power of -1, which is not a whole number. So this is not a term.
Yeah, not a whole number. Remember, you can't have negative powers, negative exponents. Okay, one more example. What about pi? Is this a term? Yeah, good job. So pi is a term because pi is equivalent to pi times x to the power of 0. Since 0 is a whole number and pi is a real number, then this is indeed a term. David, do you want to move on or?
We should do another example. So
Sure.
is 5x plus t a term?
Yes. Yeah. Oh, wait. Okay.
Wait,
Sorry.
no. Okay.
I'm mistaken.
So yeah, this is kind of important. I don't think we technically mentioned it in the definition, but a term is only a term if it's all the parts of it are multiplied together without addition and subtraction. So if we look at this thing, right, there's technically two terms. So we have the term 5x, and we also have the term t. Yeah. So this is kind of getting into
terms.
the polynomials part of it.
Hint, this is called a binomial.
Yeah.
Which we'll talk about later. Okay.
Edward, what do you mean by isn't that two?
He meant like, is that two terms? Yeah.
Oh, okay, that makes sense.
Yeah, it's two terms. It's not one term.
Yeah, so this actually kind of gets into our definition of what is a polynomial. So essentially, a polynomial is just a sum of multiple terms. And do note that when we mean sum, there's kind of like a loose definition of sum. So it also includes subtraction. So for example, 5x plus t is a polynomial because it's a sum of two terms, but also 5x minus t is also a polynomial because technically you're adding negative t. It's kind of confusing, but it's still polynomial. Yeah. So our first polynomial is what is called a monomial. So a monomial is technically just an interchangeable name for a term. There's essentially just one term. So for example, x. So an example, this would be x, or like 4x squared. Those would be a monomial, or you could just also call them a term. So our next polynomial, as Kevin mentioned before, is what is called a binomial. So it's essentially an expression consisting of two terms. So some examples of this would be like x plus 5. Or something like x squared minus x.
Okay, so I think to know. Okay, so what do you guys think about x plus x? Is that a binomial or a monomial? Monomial. Yeah. So when you have a binomial like this, you can actually collect the like terms. So that equals to 2x, which is a monomial. So before identifying if it's a monomial or binomial, always try to combine the like terms.
Mhm. And our next definition is a trinomial. And as its name suggests, it's a expression made up of 3 terms. So an example of this will be like x squared plus x plus 1. And this is also the type of polynomial that you'll encounter the most in high school. And we have the most general term, which is a polynomial. It essentially describes any number of terms. So, but it normally only describes anything above 3 terms because we don't want to call something like quadnomial. That kind of sounds weird. So we just describe anything that has more than 3 terms, just polynomials. Yeah. So we can have something like x to the power of 5 plus x to the power of 4, and then plus x to the power of 3, and then plus x to the power of 2, and then plus x, and then plus 1. We would call that a polynomial. So the next thing we're going to go over is what is a degree? So when we refer to degree, we usually refer to 2 things, which is either a degree of a term or the degree of a polynomial. So we'll first talk about what is a degree of a term. So we can have an example of a term. We have something like, what do you think of, Kevin?
We can do like f. Okay, sorry, 5 to the power. Okay, sorry, f times. Wait, what am I saying? 5x to the power of 5, y to the power of 7.
Yeah. So a degree of a term is essentially all the exponent, all the powers on the variables added together. So in this case, we see that the power on the variable is a 5 and 7. So what we do is that we just add 5 and 7 together, and we get that the degree of the term would be equal to 12. And do note that it's only on the variables. So for example, if we have something like 4 squared times x squared times y squared. So in this case, we only have a degree of 2 because we're only counting the exponents on the variables. Because we can also just simplify the 4 squared into a 16, and it technically only has a exponent of 1, which also we shouldn't add on there. So that's the degree of a term.
Wait, did you say y squared as well?
Oh, yeah. I
Okay,
don't
so-
remember though. So yeah, but also, yeah, include all the variables.
So it's the degree is 4.
And
Okay.
the next thing that we're going to,
We should give some examples, do you think?
oh yeah, that's true.
Okay.
We can have x times y to the power of 5. And then put your answer in the chat.
It'd be
That is
6.
yes, it's 6, because remember, the x technically has a power of 1, because if it has a power of 0, then it would just be 1. Yeah.
What about x to the power of -1 times y to the power of 5? No, it wouldn't actually be a term. That was a trick
Yeah.
question. So this is actually not a term. We only talk about degrees when we refer to terms. Okay. So not a term. What about x to the power of 3 times y to the power of 2 times z to the power of 5? 10. Yeah,
Yes.
good job. David, do you want to do one more?
Oh, wait.
Or
I think they get the idea of it.
okay, sure.
Okay, so what we're going to go over now is the degree of a polynomial. So what it is that it's technically the degree of the term with the highest degree. So it's kind of confusing, but we'll do a lot of examples for this. So we could have the polynomial 4x cubed 4x cubed plus x to the power 5 plus 7x squared. So the first step to finding the degree of a polynomial is to find the degree of all its terms. So in this case, the degree of the term for 4x cubed is 3. And then for x to the power 5 is 5. And if for 7x squared, that's 2. And then what we do is that we spot the highest degree. So in this case, it would be the 5. And it would mean that 5 would be the degree of the polynomial. So we should do another example. So we can have 5x squared plus x cubed y squared subtract 6x squared y cubed. So again, we find the degree of each term. So for the first one, it's 2. And then for the second one, it's 3 plus 2, which is 5. And then for the last one, it's 2 plus 3, which is 5 again. So note that even though we technically have 2 degrees, 2 terms with the same degree, we don't really care about that. All we care about is the number itself. So in this case, it will be 5 no matter which one you choose.
Just the highest.
Yeah. So where degree of the polynomial come in place is when we are writing out a polynomial, like kind of standardizing it. So what we do is that we usually write a polynomial with the highest degree terms first, and then the lowest degrees terms last. So for let's use the example of like 4x cubed plus x to the power 5 plus 7x squared. So if we are rewriting that with the highest degree first, we rewrite it as x to the power 5 plus 4x cubed and then plus 7x squared. It doesn't really matter, but we just tend to like having the highest degrees first. So we should give them an example of this. So we should do 5x squared.
Don't I just use the second one?
Well, yeah, that would work.
Okay.
Well, I was gonna let them like write it out in descending order.
Oh, okay, yeah. We can go with your idea then.
Okay, let's give a simple one. So for like 5x squared plus x cubed plus 2x. So you guys can just write that down in chat with a descending degree. So highest degrees first, lowest degrees last.
Three, two, one. Yeah.
Yeah, that would be correct.
I know this like standardizing the exponents may seem kind of useless right now, but trust me, when you get to grade 11, doing this will save you much more time. It'll make things easier.
Should we talk about the next thing?
Sure.
Okay, so based on this degree of a polynomials thing, we can also get another definition called the leading coefficient. So the leading coefficient of a polynomial is just the coefficient of the highest degree term. So when we take a look at yes.
Highest coefficient of a term. Do you guys all know what a coefficient means?
I don't know if highest coefficient really like describes it.
Coefficient of the term with the highest coefficient?
Well, no, it's like I think the leading coefficient is the coefficient of the highest degree term.
Okay, yeah, that sounds better. Coefficient of the term with the highest degree?
Yes.
Okay.
So this is also where like the descending order of degrees come into play. Like you can just spot the first coefficient you see in the polynomial, and if it's in descending degree, that's also the leading coefficient. So we can take a look at a polynomial like 5 times x to the 4, subtract x to the 3, plus 3x squared, and then plus 4. So in this case, we see, oh, not 4x. Okay, yeah. So in this case, we see that the term with the highest degree is 5x to the power 4. And then the leading coefficient will be the coefficient of that term. So with the leading coefficient of the polynomial will be 5. Yeah, so looking at this polynomial again, we can also get another definition, which is a constant. So the constant would always, well, actually not always be the last term, but it's a term without a variable. So in this case, it would be 4. And it's named a constant because the 4 never changes. It never changes value, no matter how you like manipulate the polynomial.
Basically, you can think of a constant just as a number.
Yes. We should give an example of this for them to do. So we got something like 3x squared. Subtract 5x to the power 5. And plus x to the power 4. So could you please type into the chat the leading coefficient of this polynomial and the constant?
Five is correct for the leading coefficient.
Well, it's almost correct because in this case, that term has a negative sign in front. So the leading coefficient will be -5. And for the constant, even though it doesn't says that, we can always assume that if there is no constant like being shown, it's always 0 because adding 0 does nothing. So
yeah. Should we give another example?
Why
not?
Yeah.
Okay.
So we can have a polynomial 5x squared plus 3 plus x cubed plus 2x. And please type in the leading coefficient and constant. And yes, that will be correct. Oh, Edward, your constant is not 0 because in this case we have the number 3 in there. It's kind of hidden in there. And then yes, the leading coefficient is 1. And should we move on?
Yeah, sure.
Okay. So the next thing we're going to talk about is collecting like terms, which also gets into adding and subtracting polynomials. So if we remember earlier, we had an example where it was x plus x. And even though it looked like a binomial, it was technically only a monomial because we can always simplify the 2x's into a 2x, the term. So we can also take another example of this. We can have x squared plus 2x squared. So it kind of looks like a binomial as well, but we realize that we can technically combine them together to a 3x squared. So the trick to combining terms is that the variables have to be the same and the exponents have to be the same. So if we have something like x cubed plus 2x squared, that wouldn't be possible because although the variables are the same, the exponents are different. So there's no way to combine it and it's a binomial. So we can do an example of this. For example, we have 4x to the power of 4 plus 2x cubed minus 4x plus x cubed, and then subtract x to the power 4. So to make this a little bit easier, we could visually represent, like group them together. So we notice that we have 4x to the power 4 and negative 4x, negative x to the power 4. So those will be grouped together. So when we subtract them, we get 3x to the 4. And then we also spot that we also have 2x cubes in there. So when we add those, we get 3x cubed. And we can't find a pair for the negative 4x, so we just put it at the very end. And that's kind of the basics for adding and subtracting polynomials. We should do more examples.
Sure. Okay, so that's one you guys gotta try out. Tell me if the following expression is a monomial, binomial, trinomial, or polynomial. 4x to the power 5. David, you can like make the next few terms.
Okay. Plus x squared, subtract 3x to the power 5 plus x plus 2x squared.
And then maybe like minus
minus x. Yeah, good idea.
Okay. So is this monomial, binomial, trinomial, or polynomial? Polynomial, let's see. This would actually not be a polynomial once you combine all the like terms.
Yeah.
Trinomial, it's actually not a trinomial either. Close though.
Actually, you know what? Polynomial kind of describes it, because polynomials just mean any amount of terms, but
Yeah, but we should try to be like more specific.
yeah.
Binomial, yeah.
Yes, that would be correct. So we can see that we can combine the x to the power 5s. So that would give us x to the power 5 with 1 as a coefficient. And then we also notice that there's the x squared. So we can add those two together, and that gives us 3x squared. And then we can see that the x and the negative x just cancels out and gives us 0. So we just don't put anything there. And that will be a binomial. Okay. Should we give another example?
Sure.
With more variables. Okay, so we have 3x times y squared. And then plus 4y. And plus 5x squared. Subtract xy squared. And subtract 2y. And here, how should we what is the answers for this? How should we list it out?
Monomial or something?
Oh yeah, that works.
Trinomial?
Yeah,
David? Yes.
I think that is correct.
Yeah, I think so too. Okay.
So in this case, we notice that we have two variables, but they still match because xy squared and xy squared. So we get 2xy squared when we subtract them. Oh yeah, and remember when you're subtracting terms, you just subtract the coefficients. You don't really have to worry about, yeah, you just have to subtract the coefficients. That's like the easier way to think of it. And we notice that there's a pair for the y's. So we have 2y at the plus 2y at the very end. And then we just have a plus 5x squared that we can't find any pairs of. So, and that would be a trinomial. So you're correct.
Good job. One more, or should we move on?
What do you feel like?
I think we could do one more.
Yeah.
Okay.
Should we do this one?
Sure.
It's kind of a long one.
Okay, yeah. X to the power
Wait.
4.
We should make that a negative instead.
Oh, okay, sure. Like this part negative?
Yeah.
Okay, sure. All right. Same question. Is this a monomial, binomial, trinomial, or polynomial? Trinomial?
I don't think that's correct.
Yeah, close.
It's very close. Should we just do it?
Sure.
Okay, so yeah, the correct answer will be polynomial. So there's actually 4 terms. So we realize that x to the power 4 has no pair, so we just put it there. And then we can do 3x squared. And we know that there is a term, but we notice that the polynomials within brackets with a negative sign in front, so we have to apply that negative sign. So we get 2x squared, and then we check out the 5x, and we see that there's a negative 2x in the back, and that gives us plus 3x. And there is a negative 3x cubed. And so we'll have 4 terms, and that will be a polynomial.
Yep. Let me just make this look nicer.
Descending order.
Yes.
Should
Okay.
we move on to multiplying polynomials?
Yeah, sure.
Yeah, so okay, we're gonna move on to multiplying polynomials, which is where it gets very interesting and kind of complicated. So in high school, when you multiply polynomials, remember these 4 letters or one word. It's FOIL. So FOIL. So what it stands for is a first, outside, inside, last. And what it basically describes is the order for which we multiply binomials. So it's going to be different for like which type of, for example, if you have a trinomial multiplied together, that's going to have a different set, but this is just for binomials and it's kind of like a nice way to remember it. So we should have an example of this. So we can multiply. Yeah, when you get like the roughly how it works, you can also apply it to other polynomials. So we can multiply the binomial. Wait, it's kind of weird. We can multiply the binomial 10 plus x to 10 plus x. It's gonna work out very well. Okay, so what we're gonna do is that we're gonna follow FOIL. So it's always gonna be multiplication that we're applying. So what we do is that we look at the F, which stands for first. So we see that there's 2 terms, and we just multiply the first. What'd you call it?
First of each binomial, like the first term.
The first term of the binomial. So in this case, it's 10 multiplied by 10, which gives us 100. And then what we're going to do is that we're going to do outside. So it's most left and most right term of the binomial. So in this case, it will be 10 because it's on the outside, and x would be on the outside for the other term. And that gives us 10x. And then what we do is that we do inside, which is again 10 and x. So we multiply 10 and x together, and then we get x10. Yeah. And then what we do is that we do the last terms, which is our both x's, and we can express it as x squared. And then what we do is that we just add all these results together, and we get x squared. Oh, yeah, that would be it. Plus 10x. No, it's fine. We can change it later.
Sure.
X squared, and then we can organize it a little better. We have x squared plus 20x plus 100. And that would be the result of the multiplication.
Yeah. Please don't actually write x10. I just did that for demonstration purposes.
So we can do another one.
Yeah. Do you want to do like the classic a plus b times a plus b?
Oh, sure.
Okay.
Yeah, a plus b squared. That will be another way to put it.
Okay, sure.
And oh, okay. Yeah, and then we could like expand that out, and we get a plus b plus times a plus b. And note that this type of form, where we can't break it down any further, is called a factor form, and the result we get is called an expanded form.
So factored form. Do people also like say simplified form or something?
Yeah, it's like some people also call it that.
Yeah. Okay.
So we can do it this time with variables to make it a little bit better. So we can see that we do the first terms, which is a and a, so we get a squared. And then we do the outside terms, which is a and b, so we get a times b. And then we do the inside, which is b and a, so we can do b and a. And then we do the last terms, which are b again, so b squared. And then what we do is that we add all these together, and we get a squared plus ab plus ba plus b squared. And then we could just simplify it a little bit. We could get a squared plus 2ab plus b squared.
Yeah, remember this formula. It's really important. So a plus b squared is equal to a squared plus 2ab plus b squared. This is probably one of the most important formulas you'll learn in high school.
Yeah. If you remember that formula really well, you don't even need to do FOIL anymore for binomials. If you get something squared, you could just know, I'll just apply this formula and get the result straight away.
Yeah, exactly. Do you want to do like a minus b squared?
Yeah, that's a good idea.
Okay.
That might be going into the next lesson.
That's fine.
Yeah.
Because I think it really ties into this FOIL, so
Yes.
we should just do it.
Yeah. So when you encounter something like a minus b and then that binomial squared, we call this a difference of squares. So there's actually a really easy formula for this one. So if you do remember that one later, you can spend like 3 seconds and then solve it. But we're just going to go through FOIL. So what we're going to do is that we're going to do the first.
Wait, David,
Oh.
isn't like difference of squares a plus b times a minus b?
Yeah.
But we're doing a minus b squared.
Oh wait, I'm really
Okay,
don't worry
fine.
about it.
It's okay. Not difference of squares.
Yeah, okay, so that's not gonna go into the next lesson.
Yeah.
Yeah, difference of squares is a whole nother thing. Not this. Please
Yeah.
don't remember what I said.
Yeah, difference of squares is a plus b times a minus b, but we have a minus b times
Yeah.
a minus b.
Which is a squared minus b squared, so.
Yeah, it's fine. Just
Yeah.
yeah.
Okay, so what we're gonna do is that we're gonna do the first terms as in FOIL. So we do a times a, which is a squared. And then we do the outside, and we notice that the b is negative. So we do a times negative b, which is negative ab. And then we do the inside, which is negative b and a. So we get negative ba. And then we see that there's two negative b's, but we're going to multiply it together anyway, so it's going to become positive. So even though it's negative, squared gives you a positive. So we can combine all these together, and we get a squared minus ab. Oh, also minus 2ab.
Minus 2ab.
And then plus b squared.
Again, super, super important formula. Please remember this formula.
Oh yeah, and do remember that the first, okay, so when you multiply two binomials, it's always going to result in a trinomial. That is not going to change anytime soon. And when you have a trinomial, realize that the a squared and the b squared is always positive because they're multiplied together. So if you somehow multiply two binomials and you somehow didn't get a trinomial, or somehow the a squared and the b squared in there becomes negative, then you can assume that you probably did something wrong.
Yeah. Okay,
So should
want to
we
move on?
Yes.
Sure.
And that kind of moves into the next section of checking over your work when you're multiplying polynomials. So as I said before, when you multiply two binomials, you're always going to get a trinomial, and that trinomial will always have a degree of 2. So when we remember back to the degree of a polynomial, that number will always be 2.
Degree 2. Okay, want to give them some examples? Some things for them to try out?
So we can do like multiply x plus 1 with x plus 2. And then we can see how like it always ends up with degree 2. So when we multiply those together, we get x squared. Actually, we should probably go with the FOIL thing.
I thought like we should let them do it.
Oh yeah, that's a genius
Yeah.
idea.
Yeah.
Yeah. So if you please type in chat the multiplied, well, the product of these two binomials.
Yeah. Okay. FOIL.
You can simplify that even further.
Yeah. You messed up on the last term. You messed up on the last term because 1 times 2. Oh, sorry.
Yeah, no, it's fine. You continue talking. You talk first.
No, it's okay. It's okay. It's okay.
Yeah.
Okay.
Okay, you talk.
All right. So like for your last term, you wrote 2x, but if we use the FOIL method, then it should be 1 times 2. Yeah, it should be 2. Yeah.
This is also a perfect demonstration of error checking. We can see that when we multiplied the two binomials, we didn't end up with a trinomial. So we can then assume that we probably did something wrong and we should double check.
Yep.
And if you have like a super long polynomial that you're like multiplying and you don't really have like two binomials multiplied together and you can't use this trinomial thing, what you should do is that you should actually just try to input a random number for x into the original like unmultiplied equation, unmultiplied expression, and then put that exact same x into the product and see if the answers are equal. So in this case, right, we can assume that like, oh, we don't know if this product that we got is correct. So what we could do is that we could assume x is equal to the number 2. And then we could just solve for both sides. So 2 plus 1 times 2 plus 2, we get 2 squared plus 3 times 2 plus 2. And then we see that on the left side, we get 12. And on the right side, we also get 12. So we can assume that, hey, we probably did this right.
Yep. Yes, Edward, good job. You got it correct. It's okay. Typos can happen sometimes. Don't worry. Okay. Should we do like one more example? Or like for them to try out?
Yeah, we could. Let's do some bigger numbers. Here, wait, let's put a coefficient on the x.
Sure.
You can do 2x plus 2. Okay, wait, that isn't that good of an idea. 2x plus 3, there we go. Because you could kind of factor that 2 out.
Oh.
And then x plus 1. Yeah, so if you guys have an answer, you can type it in chat.
Uh, 2x squared plus 5x plus 3.
Yeah, that's correct.
Okay.
Should we move on?
Yeah.
Yeah, so the next thing we're going to talk about is factoring out the GCF so we can make the equation easier. So in the previous example, I said we had to multiply, yeah, here, I'll let you write that out. So in the previous example, I said that we should multiply 2x plus 2 with x plus 1. So we can have that as an example. And 2x plus 2 times x plus 1. So this was kind of bad example for that type of problem, because in this case, we realized that the first binomial, each of the terms has a greatest common factor of 2. So what we could do is that we could divide that entire binomial by 2 to get 2 times x plus 1. And that'll just end up making the expression really easy to solve. So we have 2x plus 1 squared. And then we could use the squared kind of binomial formula that we remember, and we get 2 times, 2 times x squared plus 2x plus 1. And we can then multiply the 2 into each of the terms.
Notice how this form right here, that's actually not the expanded form. That's still the factored form because you're multiplying two expressions, right? So if on a test you're asked to find the expanded form, then you have to like simplify further and multiply this 2 to each term. So this is the factored form. And this is the expanded form. Okay. Right.
Okay, so we can do a longer example. So we can have 3x cubed plus 6x squared plus 12x. Yeah, I think that's it. And then we just gotta like simplify that.
Sure.
Okay, so I think we should turn it into a factored form. Okay.
Yep.
So here we notice that, first off, for the greatest common factor of the coefficients, we realize that the GCF is 3. So we can obviously divide out that 3 from the entire trinomial. So in this, yes, so 3, 6, and 12. So we get 3. And then what we can do is that we could divide that 3 out from the entire trinomial, and we get x cubed. Oh.
If you want to, I thought we should
Yeah.
just, okay, sure, we can do it your way
Wait,
as well.
Kevin, you should talk about your way as well.
Okay. Okay, so what I was thinking is like we first determine the GCF of all 3 of these terms, and then we collect them out. But like if we want to do it like David's one step at a time, then that works as well.
Let's do your way, actually.
Yeah, this way is quicker. So like we see that just by intuition, all of these terms has a 3x inside of them. So the GCF is 3x. And if we extract 3x from each of these terms, we get 3x times x to the power 2 times 2 plus 2 x plus 4. Is that correct?
Yeah, I think that is correct.
Okay.
Should we do another example?
Sure.
Should we let them do it this time?
Yeah, that's good.
Okay. So we can have 5x cubed plus x squared. So we can have a simple one to start. Should we make them type out the GCF or like the factored form?
Maybe like the factored form.
Yeah.
Oh,
you're very, very close. What you did is correct, but you could take it a one step further. Yes.
Yeah.
Another x. Yep. So when we find that the GCF of the binomial is x squared, so we can take that out and we get x squared times 5x and plus 1. And remember that we're dividing by x squared, so we're not going to end up with 0 at the end. So we're always going to end up with 1.
Oh,
so
yeah.
Divide x squared by x squared. We should do another one, but like bigger. So we can have 4x to the power 4 plus 2x cubed Plus 6x. And if you have the factored form, you can type it in chat.
Yeah.
Yeah, I think that's correct.
Good job. GCF is 2x. And I think
Awesome.
your next lesson will show you like a concrete way to find the GCF. But for now, since we're dealing with like small numbers, you can just use your intuition. So 2x.
Times 2x cubed. It's kind of funny because I have it wrong on the answer sheet.
Oh, really? Huh.
Yeah.
Okay. All right.
I think that's it for the lesson. So should we do a little bit of worksheets?
Yeah. Worksheets.
Yay. Okay. What's like an interesting thing we could do?
Maybe we can do like 5J. Do you think that's good?
Yeah, I think 5J is interesting.
Yeah.
Yeah. So if you have the expanded form of 5J, you can type it in chat.
Oh, Edward responded. You can simplify it.
Yeah. Yes, that would be correct.
Yep. So, do you want me to explain or do you want me to explain?
You can explain.
Okay. So if we use the FOIL method, first we get 16a squared. Outside we get 12a. Inside we get 12a. Sorry, negative 12a. And then last we get negative 9. So if we collect the like terms, then we have 16a squared minus 9. This is what David referred to as the difference of squares.
Oh yeah, and something to note that those two binomials are conjugate pairs. So that's a thing that you'll learn a little bit later, but it's also called a conjugate pair. So what's another one we should do?
You choose.
Okay. We should do the should we do x where it's a binomial multiplied by the trinomial?
Oh yeah, sure.
Okay, actually, should we do this as well together?
Yeah, we should probably do it together.
Yeah, because we didn't teach this. Okay. Yeah, so here we have a binomial multiplied by trinomial, so we really can't use a FOIL method anymore, but we can kind of replicate it. So what I like to do is that I like to just pick the first term out of the binomial and multiply by every single term of the trinomial. So a times 2a squared times negative 4a times negative 1. And then I choose the second term. Oh yeah, you should probably write that out first.
Yeah, okay.
Yeah. And then what we do is that I just choose the second term of the binomial and then multiply it again by every term in the trinomial. So the negative 3 just multiplies everything. And then we get negative 6a squared plus 12a plus 3. And then we could just simplify this equation. We realize that the 2a cubed is just there. And then we have negative 10a squared and then 11a and then plus 3. And I believe that is the right answer, but I should just check.
Okay.
Do. Huh. Yep, that is correct. Yay.
Okay.
Okay. Should we choose another? We have time for another one.
Yeah.
Here,
Which
should we
one do
choose a
you?
different type? Oh yeah, we
Like-
should do. The factor ones? I mean,
Do you want to?
I think we can.
Okay.
Kind of did teach about it.
Oh yeah, that's true. We'll do it next lesson.
Yeah. I think the word problems will take too long.
Yeah. I think we should just give an example.
Yeah.
Okay. So what have we learned so far? Oh, we could also do do a question where it's like a plus b times a minus b.
Oh yeah.
So yeah.
This is a difference of squares. Yeah, so this is actually a pretty important thing you gotta know. Like, I'm pretty sure your high school teachers will just force you to remember it.
Definitely.
Yeah, so we can do a FOIL first.
Wait, whoa, FOIML, where the M stands for middle.
Wait, what?
Oh, I think he's trying to say like the middle gets canceled out.
Oh yeah.
Yeah, that works. So first.
So we get a times a, which is a squared. And then for the outside, we get negative ab. And then for the inside, you get positive ba. And then we have, for the last one, negative b squared. So when we write this out, we get a squared minus ab plus ba minus b squared. So yeah, we get a squared minus b squared. So this is why it's kind of called difference of squares, because we have a squared subtract b squared. Yeah, so this is like a pretty important thing you got to remember.
In essence, the middle terms just get canceled out with each other because we have a negative AB and we have a plus AB. So they just get canceled out. And Edward, yeah, that's a good acronym. So he meant binomial times trinomial. So like first, outside, inside, middle. Okay, yeah, that's
Yeah.
smart. Okay, it's 4:59. Should we just conclude the lesson?
Oh, boy, yes, just add as many m's as you need.
Smart. Oh, it's 5. Okay. That
Okay.
lesson went by pretty fast.
Yes.
Okay, well, thank you all for coming. It was fun to see you all again.
Yep. And if you're still a little bit confused, we'll upload this lesson onto YouTube. So you can always watch the video. Okay, yep. See you guys later.
See you guys later.